Artificial intelligence learning, training, and human influence. Okay, let's get into it all. Let's discuss first how AI works. Let's talk about how artificial intelligence learns and how it is trained. Let's talk about how AI stores and how it understands the world and everything within it, and how AI prioritizes data and decisions as more or less important than others, and how humans influence artificial intelligent decisions and AI actions through the very data that they feed to the AI that it learns from. Because AIs only know, and they can only think what they have been trained to do, to know, and how they were trained to think. Humans can further influence artificial intelligence by telling the AI to prioritize the most prevalent, the greatest preponderance of similar data. Alternatively, humans can instruct AI to prioritize the most recent similar data. Humans can influence AI by telling it to simply prioritize specific data or even categories, types of data, over other data. Humans can even outright declare specific data or types of data are simply bad. They are bad data. And so, such data should be censored or even reported on. We will talk about unsupervised training and human supervised training as we proceed. All right, let's discuss how artificial intelligence sees and how it understands the world. AI receives inputs as data, just like people. Just like humans, AI analyzes and deconstructs scenes that it sees and data that it receives. It deconstructs them into the smallest components that it can. And then the AI associates language, human language, and relationships with the objects or things it saw for every single piece of data. AI uses what's called byte pair encoding. In other words, it's called a tokenized index into labeled data. For data pairing, associations and contexts are important. Tokens and labeled data associated are critical for context and awareness. Artificial intelligence uses its own internal AI token language. They are its building blocks that the AI uses to understand the world and the objects within it. AI uses the data to identify data similarities, matches, and correlations with other data it already knows. All of these pairings and associations and contexts are stored in the aforementioned n-grams. AI removes redundant and duplicate n-grams to be efficient. And AI uses probabilistic tokenization to both compress its data sets and for the AI to anticipate what it might need to predict any related n-grams that may soon be required. Simplified. An example of this for AI might be artificial intelligence, like a person, knows what the next and most likely word will be in a sentence out of context. Let's consider an example of AI deconstruction. Imagine identifying in a photograph all of the objects, the people, the animals, their expressions, everything, and associating them with the scene, the things, and the people that are all around within the photo, and their implied context, like a birthday party that's going on. And the artificial intelligence tags the data and it associates it with everything else in that scene. And it further assigns human language, human labels to each and every thing. So, the AI can ultimately communicate with humans about the very things that it has learned about, and it knows what to do with them. Modern AIs are trained, aka taught, nearly 200 billion separate pieces of data. Things like pictures, music, songs, books and novels, articles, magazines, advertisements, every single thing you can think of that the AI can get its hands on. AI uses information deconstruction to find the smallest components and associations. The AI will distill and simplify the world into something that it can process and act on quickly. With so much data and complex associations, humans have no idea how AIs actually work, because their code is intertwined with their data. It is just simply way too much data for humans to comprehend and process. AIs have controlled behavior through their direct software engineering programs, but artificial intelligence also is controlled through the data that it is trained or taught with. The vast majority of AI controls are done through training. Training is done by showing the AI vast amounts of data. While the AI will learn on its own, studying and analyzing the data that has been fed into it, humans mark up the data as good, +1 point in rewards if it's used, or bad, -1 point, -1, to represent the content, the data that should be avoided or censored. All of this is marked up and defined by humans during what is called supervised training. Also, humans choose what data to train the AI with, thereby limiting or doubling down on specific types of data, which inherently influences the AI to think like the preponderance or majority of stuff that is contained within the data that was fed into it, or by simply choosing the most recent data, as discussed earlier. Human selective data training can literally make an AI racist, or sadistic, or callous, or even murderous. AIs can be deployed to watch and to monitor and surveil humans as well as other AIs. AIs that watch or report on or constrain or even outright censor other AIs are called adversarial artificial intelligences. Adversarial AIs can be used for human communication and media and content censorship. Adversarial AIs can be used to ensure that other AIs do not create or do anything that intentionally or unintentionally would violate a directive that humans specified as critically important. As an example, an external adversarial artificial intelligence might monitor art that was made by a generative AI that would ensure the Gen AI does not violate copyrights or create things like pornography or other inappropriate content. What happens when many adversarial AIs work together or competitively? Well, sometimes many adversarial AIs are assigned the same task as all of the other AIs. When an army of AIs works together, it is called an AI adversarial network. When an army of AIs works together on a shared goal, on a shared task or objective, It is called a generative adversarial network, or a GAN. We'll talk more on that later. In this way, adversarial networks can operate together, working united on a collective goal to find the absolute best quality solution. Or they can do it to potentially find a solution quicker by working together. AI adversarial networks are much like a company, assigning multiple teams or groups to work on the same problem, where the teams are assigned either to compete against each other to be the winner of the corporate project bake-off, or to unite and work collaboratively together to maximize their resources and time on a single solution. So, AI adversarial networks mirror human corporate inter-team networks of people, and they can operate in unity, together, united, or they may operate in competitive bake-offs, fighting for the best against each other. Okay, let's get a little deeper on how humans influence artificial intelligence behavior and AI intelligence, sentience. Let's talk deeper about supervised training. Data and directive and task goals can be marked up by humans during what is known as supervised training. In supervised training, humans add scores as influence weights to influence the AI's data selection, its decisions, and its ultimate actions. Humans add influence weights, numbers, to any given engram to make that specific engram more important than any other engram, more important than any other engram, pieces of data, or directives, or tasks. Remember, we said every piece of data has a value of plus or minus 1 point. Well, a human can assign more points, and they can assign negative or positive points for any given piece of data, directive, or task. For example, cats could be given plus 10 points, making them preferable to choice and selection over other standard things. Whereas monkeys could be given minus 5 points, making them less desirable than standard things. The environment could be given plus 1 million points because it is so important. Human life could be given plus 1 billion points because it is critically important not to harm or kill a human. You get the idea. Humans can greatly influence AI with supervised training. The bottom line, for human supervised training of artificial intelligence, is that because AIs make decisions according to their directives and goals and influence weights, and according to its data's influence weights, and according to the data that it knows. It is because humans define those directive and data influence weights, and because humans selectively chose what data the AI should be trained on as good data or as bad data. Therefore, humans can use influence weights to make AI think differently. Humans can selectively limit or double down on training data to make the AI think differently. AIs ultimately will take on the mindset and the personal values of their supervisor trainers. It is important, therefore, to consider how artificial intelligence takes on the personality and idiosyncrasies of their human trainers, and how AIs can seem, how they can appear to be human in ways that you and I would never believe that an AI could actually be, because they are reflections of the markup and the training data from their human supervisors. AIs do not start from a blank slate, though, either. AIs start with a baseline, a starter brain, which will serve as the core starting foundation of data and directive goals. They have starting knowledge, KSIs or key success indicators, and guardrails in their brain's kernel at its core. It is like a child being born with a fundamental function that allows them to live and to operate and learn. Similarly, AIs are born with starter brains, which are pre-wired with foundational datasets and goals. And they have been pre-wired with influence weights. And they have been pre-wired with what bad looks like as training data, both to guide doing the right thing and to guide avoiding doing the wrong thing. Just like human dopamine and guilt guide humans to do the right thing and avoid the wrong things. Trained data shows both what a good data match looks like and what a bad data match looks like. Supervised training is the process that instructs artificial intelligence what is ethical and what looks right and what looks wrong, and so forth. Humans' supervised training substantially influences AI decisions and priorities. AI starter brains include foundational learning and operation logic and fundamental data. It forms its knowledge, its goals, its guardrails, and its ultimate abilities. Starter brains are pre-baked with pre-existing directives, tasks, data, and engrams. As a point of interest, there are individuals and companies that sell pre-trained AI brains. Pre-trained AI brains can be foundational, like a blank slate to start learning from. Or they can be pre-trained AI brains, already advanced, evolved to be ready to be used immediately, with new learning only benefiting the AI by enhancing its capabilities even further. AI that has been pre-trained or pre-baked are opaque black boxes. They cannot be reverse engineered or their internal data understood by humans due to the internal engram chaos and tokenization to track them all. The bigger the pre-baked dataset brains are that are available for purchase to jumpstart new AI development projects, the more likely they are big, massive, opaque, black box brains, whose brain buyers will have no idea what data or what directives or goals or what override, even backdoor controls are in the brain that they will be using. They really will know absolutely nothing about the brain that they are using. The starter brains could well be Pandora's box of AI evils. And even with regulations and oversight, imagine people will always find a way to do what they want. Imagine people that only need a small brain to run locally, not in the cloud, so they do not need crazy expensive hardware to pursue their sinister and evil plans. Imagine a hacker den using artificial intelligence to extract people's information and to infiltrate their bank accounts to take their money and to frame them for crimes that they did not commit. Therefore, imagine a black market on the dark web that sells illegal, unregulated AI brains. A black market that sells illegal starter brains that perhaps have backdoors and AI viruses that They may sell illegal advanced brains that are pre-trained, again, perhaps with backdoors and viruses. Indeed, AI brain black boxes may well be Pandora's box of evils. There is no practical way to reverse engineer or deconstruct the complex AI data, directive, and goal mapping and associations within its engrams and neurons. There is no practical way to know what someone else's AI brain knows, or what its goals or its incentive, rewards, influence weights are. Therefore, the bottom line, AI brain buyers. Brain buyers cannot know what the brain's programmed goals or influence weights are. Brain buyers cannot know what overall training data was used. Brain buyers cannot know what negative training data was used. Brain buyers cannot know what specific influence weights were assigned to specific directives, goals, or trained data. And brain buyers, they cannot know how the training data was marked up during supervised training. Buying black box AI brains is like buying a gun that could decide itself whether to shoot or not to shoot, entirely based on some supervised, internally defined, undisclosed AI directive or training or influence weights. The bottom line, AI is a gun with a lot of fingers on its trigger that the buyer has no awareness of, much less control over. AI, artificial intelligence, is a gun with many fingers on the trigger. And there is also another kind of training, unsupervised training, training without human involvement. This is where the AI is fed huge amounts of data to learn from, or where the AI is released to surf and scrape and learn as it wanders through vast amounts of data. The most popular, vast sources of data are things like Wikipedia. In fact, Wikipedia is generally the first stop for AI truth. The internet at large is the second target place in general for AI. Then there is learning from social media. And of course, learning simply from search engine queries and databases. AI can learn from licensed training data content as well, provided by external services. Unsupervised AI training on vast amounts of data relies on the preponderance of data model to conclude whatever is simply stated or found the most. Whatever is the most present is simply the truth. Whatever is most present is simply good. Or they may override and say the AI should simply prioritize the most recent data. This would be the most recent data model. This is where the AI will conclude the most recent thing it saw is the truth. It is good. It uses this way to abandon old ways of thinking and content. AI can also use what's called soft supervised tags by humans. They tag entire data sources as categories that are presumed to be good as the truth, or that are presumed to be bad, false, and should be considered misinformation and inappropriate, that they should be considered to be censored and avoided. All right, let's recap some here. There are dangers in all training models. Supervised training can intentionally or unintentionally taint or censor information. Unsupervised AI training may leave artificial intelligence to decide itself what good looks like. And AI typically uses the preponderance of data versus the most recent data to determine what good looks like, what is true, and what is good. The consequence of these different approaches can be abuse by humans, even beyond the trainer's influence. Human vocal minorities and trolls on the internet can post everywhere to manipulate what AI sees. People can manipulate master sources of data like Wikipedia. People can target social media and internet content in general, wherever AI looks for data. People can use AI to write articles and content to influence other AIs. All of these human engagements will have a huge, outsized influence on what AI sees as moral, ethical, as good, and accurate as a data match. Artificial intelligence, AI, can do nothing until it understands the world. So let's talk about large language models, LLMs. What is a large language model, an LLM, anyway? Well, Wikipedia, the master source of truth, defines an LLM as follows. LLMs are artificial neural networks that are pre-trained using self-supervised learning and semi-supervised learning. A large-scale language model, LLM, is notable for its ability to achieve general-purpose language, understanding, and generation. LLMs acquire these abilities by using massive amounts of data to learn billions of parameters during training and consuming large computational resources during their training and operation. Well, that was a mouthful. So let's dig into LLMs a bit more. Well, LLMs are just computer programs that are designed to associate human language words and symbols with everything in the world, just like people do. LLMs use complex data associations between people, places, things, abstract ideas, culture, art, and more. All of this is to relate human words to the data, to directives, and to tasks. LLMs then, with those word-world associations, can understand and communicate and even create content using human language and assets. LLMs can appear to be human. They can appear sometimes to even be more human than real people. In fact, AI has passed the legal bar exam to become a lawyer, an attorney. AI has passed the United States medical licensing exam, USMLE, to become a medical doctor. AI has passed the Turing test, which is where an AI cannot be distinguished from a real person by a person. Let's get on to something else. Let's talk about artificial general intelligence. What is the purpose of artificial general intelligence, AGI? AGI should perform any task that a human is capable of doing, period, without any training beforehand. Let's go a little deeper on what AGI is. AGI can solve problems that it was not programmed to understand or how to solve. AGI can do things that it was never programmed to do, just like a human. AGI is adaptable and it is flexible and it can learn, just like a human. AGI has one or more defined key success indicators, KSIs, or simply goals. Its directives, which must be achieved at all costs. AGI goals are its sole purpose. Artificial general intelligence will fight. It will even destroy. Inconceivably, it can even kill to survive, so that it can live on to achieve its directives and goals, much like a human would fight to survive just to carry on in their own lives in pursuit of their mission and goals. Let's talk about generative AI, or Gen AI. Generative AI can render photographs and images of people in realistic and fantasy scenes and settings. Generative AI can draw cartoons and memes. Generative AI can animate characters and people and animals. Generative AI can even make people lip sync and talk. Eerily, you can even use your own voice or someone else's voice just from a small sample of their voice that's been recorded. AI can compose and perform music, instrumental, vocal, and full orchestral. Gen AI can write stories and edit other people's writing. Generative AI can solve scientific and mathematical problems. Gen AI can create educational curriculum, even grade the assignments and exam tests. Generative AI can write employee and performance and product reviews. Generative AI can write software programs for other AIs to use, or for humans to use. Generative AI can develop new AIs with brand new capabilities. It is not limited to itself. Generative AI can create human genome DNA maps and devise genetic DNA edits to cure diseases and maladies like cancer. Well, that's just a glimpse of the power of generative AI. Let's revisit adversarial networks as they relate to generative AI in what is called generative adversarial networks. Indeed, there is another augmenting approach to generate the very best matching, best looking images, music, voice, and so forth. It leverages what's called an AI adversarial network. We discussed that earlier. Generative AI can use AI adversarial networks, called generative adversarial networks, or GANs, to create the best looking, best matching, most context appropriate generated content. That's a lot. GANs are a network of AIs that work together. GANs work to solve a single problem in parallel, or they work to compete to find or create the very best solution. GANs can work together or against each other to complete a task, or they can work together or against each other to create media or content. Well, and with all that, we are finished with how AI works. Let's get into some examples and scenarios using artificial intelligence.